Now we are going to start 31st problem. Phi is given and we know that what is E is magnitude wise d phi by dt, or if you want to give direction, minus d phi by dt. Phi is there and you know the differentiation. Not a tough task for you. It is 12t minus 5. T is given 0.25 means 1 by 4. So if we go with, we want induced current, yes. So if we will discuss this, we are getting minus 2. If we are putting minus sign, we will get plus. So I is equals to E by R. R is again given 10. So easily we got the answer 0.2 ampere. Not a big task. Next, a copper rod of length L is rotated about the end perpendicular to uniform magnetic field B with constant angular velocity omega. The induced EMF between the two ends is, when I was going to start this unit, I gave you this derivation. What was that derivation? It should be half B omega L square. So we will go with C option. 33rd, the magnitude of Earth's magnetic field at a place is B naught and the angle of dip is delta. A horizontal conductor of length L lying north-south moves eastward with velocity V. It means what will happen? What will happen in this case? It will cut the vertical component. And what is vertical component? We know that vertical component is I is given B naught sin theta and angle of dip given delta. I taught you in magnetism that there are two components of Earth's magnetic field. One is in vertical direction, one is in north-south direction. So your conductor is lying in north-south direction. So it will cut perpendicularly to vertical component. So it is the magnetic field to whose lines of force it will cut perpendicularly. Vertical component means it is your B now. And we have the formula induced EMF BLV. B means B0 sin delta, L means L, V means V. So we are going with option C, 33rd C. 34th, again a very easy task for you. Phi is given and you know that what is E. Now they want with sign, so we will put with sign, minus d phi by dt. You know the differentiation, 10t square means 20t minus 50, t is given 3. So minus 20 into 3 minus 50, 60 minus 50, 10. So we will go with minus 10. So we are going with A, 34A. 35. A conducting ring of radius 1 meter is placed in a uniform magnetic field B of 0.01 Tesla, oscillating with frequency 100 Hz with its plane at right angle to B. What will be the induced electric EMF? We know about induced EMF. What is induced EMF in this case? It is line integral of E dot dl. And what is E dot dl? dl is here 2 pi r. So it is E into, it is induced EMF and it is electric field intensity 2 pi R. And you know that what is induced EMF? EMF is d phi by dt. So it is d phi by dt is equals to E into 2 pi R. So in this way you are able to calculate E. What is the value of E? D phi. What is? It is 1 upon 2 pi R d phi by dt. Phi is given B into A. B into A. So how to calculate d phi by dt? One more thing is given, that the frequency is 100 hertz. In 1 second, 100 times your area is changing. So we have to use that 100 also. How much area is swept there? We want this BA. B is constant, but your coil is taking 100 turns. So area changing is 100 times in 1 second, and area is pi R square. So cancel this R with this R. Cancel this R with this R. Pi with pi. 2 with this 100. So we are getting 50 into B. B is 0.01 into 50, doing in SI unit. So we are getting 0.5 volt per meter. So remember this relation also. If you want to associate E, induced EMF, electric field and length, E is line integral of E dot dl. Because we know that E is equals to dV by dl. Next, 36. Coil of area 10 square centimeter has 200 turns. Magnetic field is 0.1 Weber per meter square. Perpendicular to the plane of the coil, field is reduced to 0.160 in 0.1 second. The induced EMF is, we know that what is changing here? Magnetic field is changing. So E is equals to minus d phi by dt. Actual formula minus d phi by dt. Or you can do one thing, start with sign. If sign is not given in option, they want magnitude. Finally you can take that. So what is phi? Phi is B into A. In this, A is constant. So take A outside. So minus A into magnetic field is changing. If number of turns are given, in each turn you will get this EMF. So it will be N times now. So minus NA. Final magnetic field is 0. Change in magnetic field dB means. Initially it was 0.1. Time 0.1 second. So we are getting in volt. So now we are putting the values. Minus 200, area is 10 centimeter square, means 10 into 10 to the power minus 4. Minus minus it will become plus 0.1 by 0.1 this volt. Cancel 0.1 with 0.1. 30 plus 40 minus means I am getting 0.2 volt. So going with B option, 36B. 37th, a metal rod of resistance 20 ohm is fixed along a diameter of conducting ring of radius 0.1 meter and lies in xy plane. Magnetic field in z-axis direction 50 Tesla. Ring rotates with an angular velocity omega, means 20 radian per second about its axis. About its axis. An external resistance of 10 ohm is connected across the center of the ring and the rim. The current through external resistance is, means it is a ring. They are talking about this, and it is the diameter. What they are saying in this, we will use different color. A metal rod we are putting here of resistance 20 ohm, means 10 ohm and 10 ohm. It is center. Radius is 0.1 meter with rim and center. We connected one more resistance of 10 ohm. So what is your total resistance in this circuit? The total resistance you can see, two are in parallel, one in series. So means total resistance of circuit is 10 into 10. For parallel, it is half of rod means 10 ohm. Half of rod means 10 ohm. R1 R2 upon R1 plus R2 plus 10 ohm. So total we are getting 15 ohm. Total resistance is 15 ohm. When rod is moving in there, we know that what induced EMF will get. We have a derivation, E is equals to half B omega L square. And E is equals to I into R. So what we are getting, E is equals to I into R. Half B omega L square. So for I am getting formula B omega L square by 2R. Now put the values and get the answer. What is B? 50 Tesla. What is omega? 20 radian per second. What is L? Rod's length is equal to diameter, means 0.1 into 0.1, 0.2. 0.2 into 0.2, 2R, R is 15. So remove these two zeros with these two decimals. 5 threes are. Remove this 2 with this 2. So what we are getting? We got resistor, it is 3 is there, conducting ring of radius 0.1 meter. Radius is given 0.1 meter. B is 50, yes, omega is 20, B omega. L is, oh, we are connected with this and it is rotating about its axis. So we have to take, if it is rotating about this, that this length is moving. So length is not 0.2, it should be 0.1 only, 0.1, 0.1. It is 0.1 because this disc is rotating about its axis, means like this. The axis of ring is this, means this half. Magnetic field is like this, cutting it perpendicular, it is rotating like this. So it is 0.1. R means this length is 0.1. So what we are getting, cancel 2 with 2, 2 zeros we cancelled. So we are getting, removing this decimal with these 2 0, 5 3s are 15, cancel 2 with 2, so we are getting 1 by 3 ampere, 1 by 3 ampere. So going with option B. 38. A coil has 1000 turns, 500 centimeter square area. Plane is perpendicular. Every time they give you plane perpendicular to field, otherwise EMF will not induce. The uniform magnetic field 2 into 10 to the power minus 5 Tesla. Coil is rotated through 180 degree in 0.2 second. The average EMF induced. Initially coil was at 0 angle. So what was phi 1? Phi 1 was 0 degree. What was phi 2? Rotated through 180 degree. We know that initial theta was 0 degree, then theta is 180 degree, theta 1, theta 2. First we calculate phi 1. What is the formula for phi? NBA cos theta. Theta was 0 degree, so it was NBA. When you rotate the coil by 180 degree, flux will change. Now theta is 180, cos 180 is minus 1, so we will get minus NBA. So change in flux is minus 2 NBA. So EMF should be minus d phi by dt. Minus minus, it will become plus. So 2 NBA upon time. Now everything is given. N is 1000. Magnetic field is 2 into 10 to the power minus 5 Tesla. Area is 500 centimeter square, means 10 to the power minus 4 meter square. Time in this process is 0.2 second. So remove this decimal, put 1 0 in numerator, cancel 2 with 2. What now we are getting? Only zeros. 5 into 2, 1 0 you will get from this. So 2 into 500 will give you 1000. So 10 to the power 3 and 10 to the power 3 means plus 6 and minus 5 and minus 4, it is minus 9. Minus 5, minus 4, minus 9, and plus is 3, 2, 5 and 1, 6. So what we are getting? 10 to the power, this 2 we cancelled with this 2. Now no number is there, 3 0 plus, 2 5 0 plus, 1 6 0 plus, and 9 0 minus means minus 3 0. So what we are getting? The coil is rotated through 180 degree in 0.2 second. See, it is 2 NBA, 2N number of turns 1000. B is 2 into 10 to the power minus 5. Area was 500 into 10 to the power minus 4. The plane of coil is this in 0.2 second, delta phi by delta t. So 2, this 2 and this 2 from B, A, 500 into 2000, 1000 into 1000, 10 to the power 6, 6 and 1, 7. 7 zeros we are getting positive. See, 3, 3, 6 and this one, I forget this, 7. 7 plus 9 minus. So what we are getting? minus 2. But answer is in volt, minus 2 volt. But they want in millivolt. Milli means 1 volt includes 10 to the power 3 millivolt. So we are getting 10 volt. So we are going with B. Hello students, it is 39th question. A rod of length L rotates with a uniform angular velocity omega about an axis passing through its middle point but normal to its length. In a uniform magnetic field of induction B with its direction parallel to the axis of rotation, the induced EMF between the two ends of the rod is. See, question is not very tough. What will happen here? Since we want to calculate from midpoint, it means we have to take length L by 2. So induced EMF according to the rule, what formula we derived? B omega half B omega L square. It means B omega L square by 8. L square by 8. But what will happen? We want to calculate induced EMF between two ends of the rod. Means from here and here. Since EMF is in opposite direction in both rods, opposite direction. So net EMF will become 0. So we will go with option B. 40. A metal conductor of length 1 meter rotates vertically about one of its end at angular velocity this, if horizontal component of Earth's magnetic field is given. Horizontal component means this, and your conductor is perpendicular vertical, and vertically rotates vertically. So it will cut lines of force perpendicularly to horizontal components. So what we have formula induced EMF? BLV. BLV. So we will go with our formula, what we derived there, half in terms of omega B omega L square. So everything is given. Magnetic field is 0.2 into 10 to the power minus 4 Tesla. Omega is given 5. L is 1, 1 square is 1. So what we are getting? It is 0.1. 0.1 into minus 4, 5 into 10 to the power minus 4 and minus 1, minus 5. Or you can write 50 into 10 to the power minus 6. We are doing in SI unit, minus 6 means micro. So 50 microvolt is answer. So we are going with option C. 41st. 0.1 meter long conductor carrying a current of this perpendicular to magnetic field. Mechanical power required to move the conductor with a speed of this. What is the power? We know that power is E into I. What is E? E is BLV. Everything is given now. What is B? 1.25 millitesla. Milli means minus 3. L is 0.1 meter long. V means 1 meter per second. Current is 50. So remove this decimal with 1 0. For minus 3 we will put milli. It is 1.25 into 5, 6.25. For minus 3 I am putting milli, power unit watt. So 6.25 milliwatt means 41st option C is correct. 42nd. Same, we know the self-inductance is directly proportional to n squared. 43rd, a circular coil with a cross-sectional area 4 centimeter square has 10 turns. It is placed at the center of a long solenoid that has 15 turns per centimeter. Cross-sectional area is there. Axis of coil coincides with the axis of solenoid. What is their mutual induction? Basic formula is there. M into N phi is equals to Mi. Basic formula is there. N phi is Mi. We want to calculate M. What is phi? Phi is B into A. And what is B? Mu naught N into I into A. So we got the formula. What is number of turn in secondary coil? So now everything is given. So we can put the value only. Number of turns given 50 turns per centimeter and 10 turns. 15, 10, mu naught means mu naught upon 4 pi means 4 pi into 10 to the power minus 7. Area 10 centimeter square means 10 into 10 to the power minus 4. Length is turns per centimeter means 1 centimeter means 10 to the power minus 2 meter. So everything is there now. So we have to check. We want all options are in microhenry. So remove minus 6 with that. Take this minus 2 in numerator. So what we are getting? 4 pi means 3.14. Number is 15 and rest 10 to the power. 4 we write, pi we write there, 15 is there. Now 10 to the power, take minus 2 in numerator, plus 2 and 1, 3 and minus 11. So we get minus 8 Henry. Remove minus 6. So we will get minus 2. So it is 15 into 4, 60 into 3.14 into 10 to the power minus 2 microhenry. So what we are getting here? Only calculation is there, 6 into 3. You will get 18. What is the number? 15 turns per centimeter. Circular coil with a cross-sectional area of 4 centimeter square has 10 turns. It is placed at the center of a long solenoid. The axis of coil with coincide this. What is the mutual inductance for that? So we have to take the mutual inductance means coil. We are taking number of turns in secondary coil NS. Secondary coil means we are choosing 15 turns per centimeter. It is primary. So secondary is this. So not 10. We have to take 4 centimeter square. It should be 4 centimeter square, not 10. It should be 4 centimeter square. 4. It should be 4. So what we will get now? Calculation. We do calculation again. because we are taking it primary. L is for primary and L is given for this solenoid. So it should be primary, means coil is doing the work for secondary. So now what number we are getting? 15 into 4 into 4, 16. Pi means 3.14 into 10 to the power 15, 16 pi we put. So it is number of turns 15 and 10, power 10 and 3 power plus and 11 minus. So we are getting minus 8. So 15 into 16, 180, 15 into 16, 240 into 3.14 into minus 2 micro Henry. For minus 6 I put micro and remaining minus 2 as it is. It is now micro Henry. Initially it was Henry. So 24 into 372. 72 10 this and 10 from 72. We will remove this and we will go with 7.54 micro Henry. So nearest answer is this. Next, self-inductance of a solenoid that has a cross-sectional area is there. Length 0.10 meter, 1000 turns of wires. We want to calculate, basic formula was N phi is equals to Li. Phi means for solenoid mu naught N number of turns per unit length into I is equals to Li. Phi is B into A I am putting here, cancel I with I. So L means area of cross section, 1 centimeter square means 10 to the power minus 4. Number of turns 2 times 1000 into 1000. Mu naught means 4 pi into 10 to the power minus 7 divided by L. L is 0.10 meter, 0.1. Remove decimal, put 110. 4 pi means by 3.14, 3 into 4, 12.56. It is 12.56. 10 to the power minus 4 and minus 7, minus 11 and plus 7, so minus 4 Henry. So use this. We want answer in millihenry. So we can remove minus 3 and with minus 1 we are shifting decimal. So 1.256 millihenry. So 1.26 we are going with C. Next, by change of current from 5 to 10 ampere in 0.1 second, self-inductance EMF is self-induced EMF 10 volt. Change in energy of the magnetic field. We know that what is energy? Energy's formula is half Li square. What was initial energy? Half. Self-induced EMF is 10 volt. First we have to calculate L. E is equals to L into di by dt. What is E? 10 volt. L we have to calculate. Change in current 5 ampere in 0.1 second. So we are getting 0.1 means 1 by 10. So the value of L is 10 into 0.11, 1 by 5. 1 by 5. So change in energy, half Li square. So we are getting half L is there, 1 by 5 I square. Initially it was 5 ampere, so 5 square is 25. So it was 2.5 joule. Finally it become 10 ampere, half L, 10 square means 100. 10 joule. So change in energy 10 minus 2.5, 7.5 joule. So we are going with option C. So in this way we have completed the assignment of 45 question for electromagnetic induction. Thank you.